Yep, 0.01 radian a minute, correct? And what do you want?
And then the bottom, where it says 50, I labeled that y. And do you want dy dt?
No, you do not. At what rate is the distance between the two people changing? The person is here, and here's the stationary person. At what distance is the rate between the two people? So which one do you want?
Sorry.
Which, not x, dx dt, correct. So you want dx dt, so what do you want to link together?
You want to link together d theta dt.
You want to link together theta and x. You want to link together theta and x. So how do you link together theta and x?
Through
Tangent. So tangent of theta is equal to what? Tangent of theta is equal to what?
opposite over adjacent.
So look at the diagram and tell me what it's equal to. Tangent of theta is equal to what based on the diagram on the board? On the board.
X.
Nope. Nope. Tangent is opposite over adjacent. You just said that out loud. So what? So it's y over what? 50 is not changing, so you can put it in there. Correct. Absolutely. So what do you do to both sides? With respect to? So you get secant squared theta, d theta dt. What's the derivative on the right-hand side?
Dy dt over.
dy dt times what? Tells you though, what does it tell you? You know what?
It tells you that the original angle.
That no, it tells you. What do you know? Literally, what is right here? So where do I plug that in?
Where it says next to secant.
Yeah, so you get secant squared theta times 0.01 is equal to dy d theta dt, I mean, times 1 over 50. What are we trying to find? We're trying to find dx dt. We haven't figured that out yet. So hold on, let's pause here for a second, everybody. This is a good question to do because we're trying to find, right now we have dy d theta, right? We have dy d theta. What was wrong with this original equation right here? There's a mistake, not a mistake, this isn't wrong, but is this the equation we want to use?
No, it's not.
It doesn't have x in it. So we could do this and then use dy d theta to find dx d theta. There's a way to do that. We could use a relationship between the two, or we could just find a better equation. Instead of using tangent, what could we use? I love that, yeah. So cosine of theta is equal to what, Sarah? Adjacent over hypotenuse, exactly. So what do you have to do now? Take the, yeah, so it would be good to write this as, 50 times x to the what? X to the negative 1. So now take the derivative of this, and what do you get? What's the derivative of cosine? Negative sine theta d theta dt. 50 times what? Negative x to the times dx dt. Yes. So we have to plug a bunch of stuff in. Do we know, what do we have to plug in here? Do we know d theta dt, right? We know that. So what do we plug in? Negative sine of theta is one thing, and then we put 0.01 here, and then we have what? Negative 50 times x to the negative 2 times dx dt. Now we want dx dt, so we need to get the theta value and the x value, right? Which one do you want to get first, x or theta? Let's do x. How do you figure that out? Well, you know that this is always 50 on this triangle, right? And it wants it when what is true? When theta is what? So when theta is 0.5 radians. Oh, do we already have theta? We do have theta. Nice. So we have negative sine of 0.5 radians times 0.01 is equal to negative 50 times x to the negative 2 dx dt. So we just really need to find x when this is 1/2 radians, right? How do we do that? If this is the right triangle, how do we find that? We need to find, hold on, we need to find x, right? We're trying to find x. X is right there, so what function do we use? We know cosine of 1/2 has to equal what? 50 over what? X. So x is equal to 50 over cosine of 1/2. Can someone do that on the calculator for me? What is cosine of 1/2 in radians? Cosine of 1/2 in radians, and then do 50 divided by that. What's 50 divided by cosine of 1/2 when it's in radians? What's it equal? Anybody have it? Dun dun dun.
56.97.
97. So where do we plug that in? Where do we take this?
For x.
yeah, you take this and you plug it into x. Now, can I show you on your calculator, everybody? You can store that if you wanted to. You just have to be careful at this point. This is just algebra. Does everybody in the bottom left of your calculator, do you see the STO button? If you have a number on your calculator and hit store and then put a letter in, it'll store it as that letter. And then anytime you use that letter, it uses that value. It's kind of helpful. So what do we have here? We have, is it negative here? So could we make it positive on both sides? Yeah, so what do we have here? Sine 1/2 times 0.01 is equal to 50 times, what was the actual value of x right here? 50 over cosine of 1/2, right? So we have 50 over cosine of 1/2 to the what power? -2 times dx dt. So could you use your calculator at this point and figure this all out? So what does dx dt going to equal? It's going to be equal to sine of 1/2 times 0.01, right? All over 50 times 50 over cosine of 1/2 all to the what? -2. What does -2 mean? It means you flip it over and square it, right? So what would you could you want to try simplifying this a little bit? Yeah, let's try. Dx dt is going to be equal to what? This stays the same, right? What is 0.1? That's what? 1 over 100, right? So where could we put that? That's 100 times, there's a 50 down there already, right? But then this becomes what? Cosine of 1/2 over what? Quantity what? Squared. So does some stuff here cancel? Yeah. Yeah, so let's be really careful about this. One of the 50s cancels, right? Yeah. So we could say that, just to be clear here, it's this squared and what? That squared. So what happens to one of those 50s? So this 50 cancels with that, right? And then this 50 makes this 100 into a what? 2. So what do you end up with now? Sine of 1/2 over 2 times what? Cosine 1/2 what? Squared. So now this would be, this is pretty simple. Now there's a few things we could do at this point. What's sine over cosine? Tangent. And when cosine's in the bottom, that's what? That's secant squared. So if it was me, if I wanted to write this as most simplified as I could, this would be 1/2 of sine of 1/2, like this, times what? Secant of 1/2 squared, if I wanted to simplify that further. That being said, once you get to this point right here, what could you use at this point? A calculator. You could use a calculator, yes.